Hi folks, this is Mr. Defy. This is hopefully my first successful attempt at producing my own video to post onto Schoology to help you out with some of the things that you might have seen in the classroom. And this is just to reinforce everything that I've said and everything that you might have seen. So it'll be one more resource to help you when you have to do homework, or if you are reviewing your notes and you want a little something extra to just give it that extra bit of meaning to your understanding. So what I'm going to talk about today is how to evaluate a function. So I'll put that as my title: how to evaluate a function. Okay, and I'm going to start by prefacing my examples with just giving you an idea of what a function looks like. So a function can be written as y equals something, or it can be written in a more sophisticated manner. And I want to show you the two ways that it can look. So it can be written as the following. So one is, for example, y equals 3x plus 4. And you might have seen things like that before, and it's very common, but there's a more sophisticated, beautiful way of expressing this. And it's simply by removing the y and replacing it with f of x in this case. Now, when you write it as f of x equals 3x plus 4, you're not saying anything different. You are just changing the way it looks. And the reason this might be good to do is because, number one, it is a function, which means that you have an input and an output. So this right here represents the input, as does this over here. Now, the letter f itself, well, that represents the word function. And all this means is when you're saying this, you're saying I have a function where my input can be any variable or any number. It can be any number that I want it to be. Sometimes you have that kind of freedom to choose whatever you want the input to be. Other times you are limited by inputs that are given to you to work with. And we're going to look at examples where of the second case, where the inputs are given to you and you have to provide an output from that function. So when it's set up as f of x, you're telling the function, hey, look, I have an input and I want you to give me an output. And so the function knows that whatever the input is, it has to go into this spot here. And then in this case, what you would do is whatever number you put in there, input put in there, you would then multiply it by 3, add 4, and the result would be your output, okay, or a member of your range, as we covered in class. So I'm going to go ahead and give you an example now of what this might look like. So here we go. I'll create a division right there. And I think I like this orange color, so I'm going to stick to that. So here's some examples. So the first is actually, let's go ahead and stick to what we have to our left there. So f of x is equal to 3x plus 4. And I'm going to try to evaluate this when I know that I have f of 3. Okay, now this f of 3, all that means is that my input number is a 3. That's what it's telling me. Hey, this is the number that's going into your function. It will go right over there, okay, where that x is. It will replace the x with the 3. And in order to do this, you have to understand that 3x actually means it means 3 multiplied by whatever value your x is. So in this case, because our x is 3, we will end up with the following. So we will get f of 3 is equal to 3, which is our coefficient, multiplied by 3, which is our input number, and then plus 4. So the result of that, using order of operations, would be I need to multiply my two 3's first, which would give me a 9. Then by adding 4, my result would be a 13. And that's it, I'm done. Now, I can summarize this in a conclusion by taking my input and output and saying the following. So I'll move this up. So in conclusion, if my input is 3, or if my input was 3, and my output was a 13, comma, then my ordered pair, I can represent this as an ordered pair. Then I can put this as an ordered pair. Okay, and it would look like this. It would be 3, 13. And I don't expect anybody in my class to write this conclusion paragraph or a set of sentences here, but it's just something for you to kind of put it all together and understand that, well, they do go together. The 3 makes the 13 when it's used in the function over here with the 3x plus 4. It creates that number 13 because your input is being multiplied with the coefficient of 3 and then added to 4. And it doesn't matter what we use. We will always get an output that is very unique and specific to the input that we have put in. So if I were to use a table, for example, using a table of values, if I were to use a table of values, I would have, first of all, my inputs would be here, also known as my x. My outputs would go there, also known as my y's. Okay? And sometimes, like I said earlier, we are limited by a set of inputs to use with our function. So if I were to use, let's say I were to have a 0 and a -1, we'll keep it to those two. And I should probably create more space, so I'll move that -1 a little further down, and of course write it a lot neater than that. So if I want to get my outputs, I have to go row by row. A function machine like this can only handle one input at a time. I cannot put more than one input in there at a time. Just like when you're baking cookies, you should only put one ingredient at a time, and it just helps to keep everything flowing nice and smoothly. So it's the same thing over here. If my first input is a 0, then to get my output from that, I would focus on just that 0 to begin with. So sometimes creating a division like that helps. This would then be f of 0 is equal to 3 times 0 plus 4. And that means when your input is 0, you get a 4, because 3 times 0 is 0, and when you add that to 4, you just get 4. Okay, so my ordered pair, and I will create an extra column. So ordered pairs. My ordered pairs for the first one would be 0 as my input, 4 as my output. Okay. For the second row, for the -1, which is a different input, I should expect to get a different result, but I need to do the math to make sure. So once again, you substitute, that's my input. I would multiply 3 with -1 and then add 4. So f of -1 would be -3 plus 4. Now -3 plus 4 becomes just 1. And so like that, I have an input of -1 which gives me an output of +1. And you can see my domain and range is starting to come together, where my domain is 0 and -1, and my range is made up of 4 and 1 so far. Okay, now if I wanted to, I could spend all day, all week if I wanted to, just plugging numbers in, and I would get a whole range of points that each represent an ordered pair, and then I would have a whole mess of domain numbers and range numbers that I could work with. But I don't need to do that. If I just want to practice inputting numbers into the function, I only need a couple to show you how this works. So there it is. And you can do this no matter if you have exponents or not. And I think this will help you when we get to graphing, especially when you look at the table here, where we have inputs, outputs, and then we have ordered pairs. This is the beginning of that process of moving towards graphs, which we will get to later on. So I will stop myself from saying any more about that at this time. So I hope you enjoyed this video and it was helpful, if anything. So please leave a comment, and I hope to make more of these and post them up as time goes by. Thanks for watching. Bye-bye.